Mrs. M. Priyadarshini, ME MBA, is doing PhD, is currently working as teaching fellow in the Department of IST, Anna University, Chennai. She completed a Master's in Software Engineering from Anna University. She has about 10 years of experience in handling courses for UG and PG. She was serving as Technical Evangelist for corporate over 4 years in Java Enterprise Technologies, Software Engineering, Databases, OOAD and Design Patterns. She is proficient in handling IT projects as well into concept development for enterprises. She is doing a research in the area of web services security. Her other areas of interest include software engineering, OOAD, databases, enterprise technologies and service-oriented architecture. She holds many journal publications and conference proceedings in her research area.
Welcome to UGC lecture series in Computer Science, Java Part 26. So, in this session, we are going to see about listeners, so methods of listeners and then few sample programs. So, before entering into listeners, event listeners, just we will have a recap of what we have seen about event delegation model. So, in the event delegation model, we have seen that various components available in your Java AWT package are event sources, and these event sources raises event objects, and these objects are listened by listeners. So, listeners are interfaces. This interfaces has a set of methods. These methods are implemented by the classes, which is going to have the handlers been written. So, the implementation of the methods that is available in these listeners would have been implemented in a class. So, that class helps the event manager to add the particular listener, to remove the particular listener and fire the particular event. And then as a part of your event handling, we have these listeners being registered and deregistered. So, here first we will see a list of listeners that are available, and then we will see what are all the methods that are available in those listener interfaces which need to be implemented, and we will see the purpose of each of these listeners. So, first we are into event listeners. So, to handle an event, it is necessary to create an event listener object. So, first our work is to create an event listener object. So, we have to create an object of the event listener which is going to listen to the events that is created by the components that we load on the particular Java application. So, this object will be registered with a component. When event occurs that involves the component, one of the listener methods will be called. So, here this object will be registered with a component. So, we create a listener object and associate this listener object with a particular component. So, first we need to see what are all the various components available, and whenever I have a listener, so what type of listener could listen to what type of events that is raised by the particular component. So, if I have for example, if I have a list of buttons, so I have various buttons, so then this buttons has to be registered by the listener called action listener. So, action listener will listen to the events raised by the button component. So, if I have 10 buttons, all the 10 buttons need to be registered to the particular listener object. So, then only that listener object could listen to events raised by all these buttons. So, if I do not want any particular components events to be registered and it has to be handled, so in that case I need not register the particular component with that particular listener object. So, an event listener will be an instance of listener class defined by the programmer. So, here listener class is the class which has implemented all the methods that is available in the listener. So, we know that listener is an interface and all the methods in the interface need to be implemented by the class. So, here we can see a sample program which uses action listener. So, here we are trying to import AWT components and then here the events. So, events are available only in AWT package. So, we have seen AWT components as well as Swing components are there, whereas event, all the events are available, events and the listeners are available in the AWT package and not in the Swing package. So, public class listener demo and your main method. So, I am creating a frame and I am setting it to a particular size and then I am making that to be visible. So, here I just create or instantiate the frame. So, now you can see here what is this frame. So, this frame extends frame. So, your class test frame extends frame. So, your public button test frame. So, this is the constructor and then here I am calling the base class constructor. I am setting the layout to be the flow layout and then I have a button in that. So, in that button I have created a button with the instruction, that is the action command. So, yesterday we have seen that there are two methods, one is get source and get action command. So, get source will give this name, that is B. Whenever I call get source, it means that this is the object name. Whenever I call the method get action command, this close window command will be accessed through the method that is raised by the event of this particular button component. So, here you can see that I am adding the button, then I am adding the action listener. So, this is nothing but the registration process. So, I am registering this particular button to a new listener. So, a new listener object. So, the listener object that I am trying to create is a button listener object. So, this I need to create. So, this listener object is going to implement all the methods in the listener. You can see here class button listener implements action listener, public void action perform. So, this is the method that is available in the action listener interface. So, here you can see the parameter action event. So, as and when a person presses a button, so he does some event on the button. So, this is click action. So, in that case this particular listener which is registered to this particular button will be given the information, that is firing event will happen, and so this will automatically call the handler. So, we have only one method. So, this method will be called. So, this is system.exit of 0. So, it means that on clicking that particular button, particular action perform method will be called and I exit from the system. Here we have only one button. So, you can see here I have only one button, this button is added to this button listener. So, I have only one particular action being defined. So, if I have n number of buttons here in this action perform, I need to find out which button I have clicked. So, for that only we have seen there are two methods in order to find from which event source that particular event has been generated. So, in that case what I need to do is I have to find which is the source that has generated the event. So, here we have only one button called close window. So, it means that it is used to close the window, whereas if I have multiple buttons, so then I have to find the source button which has generated that particular event and then I have to handle that accordingly. So, here we have only one button. So, we need not worry about which button has been clicked, because only one action listener object is created and only one particular button is registered to that. So, this is a listener demo program. I am creating a test frame. So, this test frame will automatically call this particular class constructor, and then here you can see that this listener has been registered to that particular button, and then when that frame gets displayed visible and then I click that particular button, this method implemented by this action listener will be executed. So, this is the standard procedure in order to write the event handling mechanism. First, I need to create a listener class. So, the class which implements the listener, and then I need to create the components which are likely to raise the particular event, and then all the components need to be registered to the particular listener object. So, automatically the components that is registered, whenever we does some action on that particular component and an event is raised, so your particular listener will be invoked and you will have the handling mechanism to be executed. So, as already told, action listener, it contains exactly one method. So, public void action perform method, and here we have action event being passed as the parameter. The above code contains the handler for action event E that occurred. So, from this action event, we have already seen in your previous session that from action event we can get the source and we can get the action command. Similarly, for each and every event we have few methods through which you can access the property of the event that has been raised. So, here just I am going to click and I am going to see what is the source or action command, and then I am going to perform my particular handling mechanism. Whereas in case of other listeners, so you can see here mouse listener. So, event handling when the mouse is clicked. So, public void mouse clicked. So, here the parameter that is your mouse event. So, this whenever a mouse is being clicked, this particular event handling mechanism will be executed in the particular class that has implemented the mouse listener. So, I have to implement all the methods. So, one of the method is mouse click. So, this will be executed when I click the mouse, and event handling when the mouse enters a component. So, whenever I try to make my mouse to enter into a particular component, this method will be used in order to handle that particular event. So, event handling when the mouse exits a component. So, you can see here mouse listener handles only mouse event. So, the parameter for all these particular event handling mechanism is mouse event. So, from mouse event we have seen in the previous session that you can access the x position, you can access the y position, and then information regarding what type of operation that you do using your particular mouse. So, from that you can gather information, and then based on that. So, for example, if I am moving my moving my mouse over a particular component, particular container. So, I can enable some information, I can show some information, like I can make a particular label visible, I can put some text contents. So, when you go in for your swing components, you can see that image icons could be loaded and it could be changed based on whenever you move your mouse on a particular component and so on. So, you can capture the mouse event. Whenever you capture the mouse event, you can very well get information regarding where your mouse has been, I mean your position of the mouse is available, and based on that you can do some action. So, here the two other methods, mouse pressed. So, this is the method when you press the mouse, and next when the mouse button is released on a particular component. So, this method will be fired. So, the event class which is raised by your environment to you will give you the information regarding the mouse event that happens. So, next is mouse motion listener. So, this is invoked when the mouse button is pressed over a component and dragged. So, this is called several times as the mouse is dragged. So, whenever I try to drag the mouse, so your start position and your end position. So, whenever you press the mouse, once you press the mouse, your mouse pressed event will be raised, and then whenever you try to drag it, and once you drag it, you will try to release your particular mouse. So, you can have the positions of your event, mouse event, while you start, that is while you press, and while you release, and while you drag multiple times, this particular mouse drag method will be called. So, based on this I can, so for example, I am dragging a particular object on my component or container. So, I can do some actions. So, again mouse moved. So, this is invoked when the mouse cursor has been moved on to the component, but no buttons have been pushed. So, I have not pushed any button, but whereas I am moving my mouse. So, in that case some mechanism has to be included. So, you can just use this particular method. Next is your window listener. So, this window listener is invoked when the window object is open. So, window open method is going to be called or invoked when I try to open a particular window. So, here I get a window event. From the window event, I can get few parameters regarding the window. So, my xy position, my height, my width, whatever I have been set. You know that window is the base class of your frame, your dialog and your applet. So, and then your window can be designed as such. So, it can be implemented as such by any of your components. So, you are going to see that in your swing, you are going to have a different type of window, different types of windows. So, here your window event will give information regarding the window that you are trying to open. Next, whenever the user attempts to close the window object from the object system menu, so then window closing event will occur. And once your window is entirely disposed, we have few other methods. So, you can see here you have a method called window closed. So, this is invoked when window object is closed as a result of calling dispose. So, you can very well hide a window as well as you can very well dispose your window. Whenever you hide your window object will be available, it is not closed. So, whenever I try to dispose that window off, then only a Windows close method will be called. So, dispose will remove the entire memory that is being occupied by your particular window. Now, we will have a short break and continue with the Windows listener and all the other listeners. Welcome after the break. So, we are discussing about the window listener, and here you can see that this method window activated is invoked when the window is set to be the active window. So, in your GUI application, you can have many frames that could be opened at one point of time. So, I may have many frames being open, and then they may be in various modes. One may be in minimized mode, one may be in maximized mode. At one particular point of time, only one particular window could be an active window. So, whenever I try to activate my particular window, this method is called. So, for example, I may have a window, and then I may try to minimize it, and then I may try to maximize it, and if I have 2 or 3 windows, I may switch between the windows. So, in that case only one particular window is set to be active. So, in that case whenever your windows get activated, this particular event handling method will be fired. So, you can see here few other methods. This is invoked when window object is no longer your active window. So, when it is being deactivated, this window deactivated method will be called. So, whenever you try to make one particular window to be activated, so the next window which is currently your active window will get deactivated. So, you can see here this method window iconify, this is invoked when the window is minimized. So, it means that you are making your window to be you are going to make your window to be an icon. So, whenever you minimize, you can notice that it is put as an icon in your taskbar. So, this is what is iconified. Whenever you try to minimize, if you want to do something, just you can use this particular method for handling. So, the next method invoked when the window is changed from minimized state to normal state. So, this is de-iconifying. So, I have my window in my taskbar, and then I try to maximize it. So, this method window de-iconified will be invoked. So, these are various methods that is available in your Windows listener. So, even we have seen how to create a frame, but even once you create your frame, the frame will not get closed unless otherwise you go and press Ctrl C in order to exit from your particular command window. Whereas here if you write all the events, so if you write your Windows close event, so in that if you have written system.exit of 0, so it means that your window is getting closed, otherwise your frame will be there, your frame will not be listened by any listener object, unless otherwise you write the handling mechanism, you register the particular window listener to your frame. So, for your frame, in order to get closed, minimized, maximized, iconified, de-iconified, activated, deactivated, for all these cases you have to write the handling mechanism. Since it is an interface, we have to implement all methods whether you are using it or not, even you can give a blank definition for that. So, here we can see a list of other listeners that are available other than what you have seen. So, these are preliminary listeners that we have seen. When adjustment value gets changed, this particular event is being raised. So, I already told you that whenever you try to move your scroll bar, this adjustment event can be raised, and automatically your adjustment listener is needed in order to handle this. So, you have you may have a slider component, and then you may have a scroll bar. So, in that case your adjustment listener should be implemented. So, next is component listener. So, this is common for all components. So, here component resize, whenever you resize the component, whenever you move the component, whenever you try to show the components and hide the components. So, in that case this will be raised. We have seen that frame is again a component. For frame also we have activate method, deactivate method. So, similarly for components, whatever may be the components, you have your text box, you have your button, all these are components. So, this listener, component listener, once you write the handling mechanism, you have to find out what is the component on which you have performed a particular action, and then based on that you have to do some actions. Whereas your window listener is very particular to that of your frame, and then your action listener is very particular for that in case of your buttons, your menu and choice menu and your list. So, next is your focus listener. So, focus listener, you have focus lost and focus gain. So, for all the components, whenever you get the focus to the component and whenever you lose focus from that particular component, this particular listener if needed need to be implemented. So, we have seen a few examples regarding the got focus and lost focus. So, when we have been discussing about your focus event. So, whenever your focus event is raised, so I have to listen that using this listener, and then I have to write the implementation. So, here next is container listener. So, the container listener, we have components added once we listen to a particular component and while we remove a component. So, containers are meant for adding the components, we do not do any specific action on the container. So, the action that we do on the container is just adding all the components and removing the components. Once we do any of these, so particular methods will be invoked for the container listener. So, next is your item listener. So, here item listener is while you change the value of the item. So, I am choosing a particular item. So, then automatically my item state changed method need to be invoked. So, this is invoked while I create, while your event source generate an item event. So, next is key listener. So, whenever I press the key, whenever I release the key and whenever I type the key, particularly these methods will be invoked. And then here all the keys, which keys need to be listened. So, in that case I have to write the listener. So, for example, whenever I am trying to press my keyboard, so this particular listener will be raised, and on pressing a particular key, if I want to handle the particular event, so in that case I can go in for checking whether the key I have pressed is this particular key, and then I can handle that mechanism. So, even we have seen how you are going to handle combination of keys even in your previous session. So, you can see here next is your mouse wheel listener. Whenever you are trying to move your mouse wheel, so this particular method will be invoked. So, the event here is mouse wheel event. So, we have seen whenever we try to use this particular event, from the event you can capture how many number of units has been moved and how many notches have been moved with respect to your mouse wheel. Next is your text listener. So, whenever you change the text, so this text event will be raised and this text change method need to be called. So, this we have already seen that whenever you press the key, whenever you release the key, so automatically text listener will also be invoked. So, in order to check what is the text content. So, I have one particular text content, I am changing the text content to another content, automatically this listener will be listened and then your text change method will be invoked. So, next is the window focus listener. So, this is particularly for, we have already seen that focus listener, that focus listener could be used in all the other components. So, here this is particularly if I want to do some action whenever I gain or lose focus with particular window. Even though we have lot of listeners in the window, this could also be included as an aid. So, whenever your window is activated, deactivated, whatever the action we do, here whenever my window gets focus, I can do certain actions on that. So, next we will move into adapter class. So, some listener interfaces define several methods. So, like your mouse listener has 5 methods and your Windows listener we have seen that we have 7 methods. So, I already told you that whenever I have an interface, all the methods need to be implemented, even though there is no need for us to handle all the events. So, how to make only one particular or few of the events to be invoked at a particular point of time in the or particular scenario. So, for that we have an option called adapter class. So, the Java API provides several adapter classes which provide empty method implementation of the listener interfaces. So, here this is a class which has implemented all the methods in the particular interface, and then whatever the method you need to write alone, you can just override it. So, whereas in case of your interface you have to implement all the methods, whereas here adapter class is a class which has implemented all the methods, and the method which you try to implement, that method only instead of implementing you can override it. So, if a programmer wishes to implement only one of the window listener method, he or she can subclass the window adapter and override the single method that he or she wishes to provide an implementation for. So, for example, I have n method, I want to code only for Windows iconified. So, in that case just I can create an instance, I mean I can inherit the adapter class and then I can use that adapter class Windows iconified method and then I can override it. Various adapter classes that are available are component adapter, container adapter, focus adapter, your key adapter, mouse motion adapter and window adapter. So, you can see whenever you have more number of methods in your interfaces, in the listener interface, so for all that you have adapters. So, here is a sample for using adapter. So, you can see here we have the frame and then the same program what we have seen earlier. So, here you can see that you have a button. So, in your previous session we have seen that you are only implementing the action listener class. Here I am also making my window to be listen. So, I am adding window listener. So, this add window listener is available in the frame, as I told you. Frame is a container and this is of type window. So, frame is a derived class of your window. So, here I am creating a new window closer. So, instead of implementing all the methods in the window listener, I am just using a window closer instance. You can see here, this is a normal button listener which is going to implement only the close process of your particular window using the button. So, using button you are trying to close it. Here you can see that you have a class called window closer which extends the window adapter. So, this window adapter is the adapter class which has implemented all the methods that is available in the window listener, and then I am going to override only one method. So, that method is nothing but window closing method. So, in this window closing method I am trying to implement the closing of your window. So, here I can close the window using the action listener which is listened for a particular button. Here otherwise you can just have an Windows adapter. So, and then I am having a class which has inherited the Windows adapter. You can see here my frame is being added with the listener object. So, this listener object will listen to the window closing event alone. So, all the other methods will have a blank definition. We do not have any definition being given for all the methods. So, only one method that I am going to override is my window closing event. So, this adapter is actually a pattern, a design pattern. This adapter is a design pattern. So, your adapter class is designed and developed based on that particular adapter pattern. So, as a summary, in this session we have seen various listeners and what all the important methods that we have in the listener, and about your adapter classes, how you can reduce the implementation of number of methods in the listeners, and then also we have seen few sample programs. So, from this session you will be able to answer questions such as list down the listener interfaces that is available in Java, how to add and remove listeners, what is an adapter and what is an adapter class, give the methods. You can give the methods in the Windows listener. So, what are all the various methods that is available in the Windows listener. So, and in your forthcoming sessions we will be having a discussion on the swing component. So, since till now we are discussing on event handling mechanism, and then we will try to move on to the components that are available in swing and then how they are handled and so on. Thank you.